going to remind you of how terrible the debugging experience can be, and then I'm going to introduce you to a future of rainbows and unicorns, and you'll love it. Let's begin. So, when you're using a source code debugger, often you have two main concerns. Either you interrupt your program too late and you miss the parts of it that actually may be important for resolving your problem, in which case you then need to restart and try again. Or you stop it too early, and then you waste time by trying to get to the parts that do matter. And if you end up making a mistake, you still have to restart and do it all over again. This is unpleasant. This is even worse if your error is not actually consistent, because then if you restart, there's no guarantee you'll actually catch the error again. It's a really bad cycle. So, let's talk about the specter of non-determinism in programs. What that means is that your program relies on behavior that it relies on factors besides the initial state of the program and any initial inputs provided to it in order to decide how it behaves. So here are two simple example programs that both initialize a random number generator, then take the first random number and decide what to do based on it. The one on the left is deterministic. That means that if you provide the same seed number on the command line to it, every time it'll behave the exact same way. The one on the right initializes the random number generator based on the current time. And that means that if you run the program over and over, it'll have a different seed every time. That is non-deterministic. So other causes include things like user input, or the way the kernel schedules your tasks, or external signals, things like this. So I want to tell you about a tool called RR, which stands for Record and Replay. And what that does is it actually records the non-deterministic behavior of your program. It notices what is non-deterministic, records that, and then later allows you to replay previous executions in the exact same way in a deterministic fashion, which is pretty cool. So in practice, that means that your debugger is now an elephant. That means that it can remember all previous knowledge of your program. And that means if you restart, everything can be exactly the same. Any non-deterministic behavior will behave exactly the same way in subsequent restarts of the process. That means that memory addresses will be exactly the same. And that means that like any watch points, any breakpoints you leave will still be valid any subsequent times you run your debugger. Also, you can travel in time, and that's pretty cool. So let's see what that means in practice. So I have a very simple web server, which occasionally, when you refresh it, instead of showing a directory listing, it actually has a bad request. And that's no good, but it's also mysterious. So if you look at the output, you notice that it prints out a useful message saying there was a problem. So let's go and take a look at this replay of the recording that I took of this in the past. And this can be hooked up to any GDB front end. So I'm going to do it in Emacs. So first, I'll set the breakpoint at that line that printed out the error.
Bigger font?
I don't think I can. It's a video.
Oh, okay.
So we have a breakpoint. We are sitting on the printf right there. Right there. And so this happens after the actual error has occurred. So that doesn't necessarily help us because we want to know what caused it. So let's go backwards in time. We're now at the previous if statement. So it's based on a variable called error flag. So let's take a look at where that is stored in memory, and we get a pointer out of it. And we'll then set a watch point on this pointer, which means we'll get a breakpoint whenever that value is changed. Now let's just run the program backwards and see what happens. And we go to the line where that is changed from 0 to 1. And that's really cool. So now we can move around in time and program state, and we can go forwards to see what happens afterwards. Or we can go backwards again. And we can keep going backwards. If we want to dig into what happened before us, we can step into functions. So we went like back in time and then a little bit forwards in time and a bit forwards some more. But if we decide we're not actually interested in that, we can then just reverse finish and go back to the color. So from here, I think we'll step back a little bit more to see what the actual problem was. Not the if statement, that's just getting us into where the error was flagged. Let's step into try parse here. So we go forwards in time again, and we start stepping forwards, And eventually we notice that there is this malloc call, an allocation that turns out it failed. And that says close the connection immediately. That looks like our problem. So we were able to figure out the cause based on the effect, which is a radical notion. And if you rerun the debugger, the watch point is still valid, and we can actually see it going forwards. It breaks in the same place now, because the pointers are all in the same place. Everything is the exact same time every time you restart your replay session. So that is what RR looks like using it. So you might think, like, how is this happening? So there's a few tricks. One is that all multi-threading gets scheduled directly into one single thread. So that means you can control how the actual interruption of, or preemption of threads happens. You'll have to trust me on that. There are reasons. Then everything, almost all non-deterministic behavior here ends up happening through system calls to the kernel. And that means the kernel's able to, or the program can intercept every system call, notice the resulting output while recording, and then when you're replaying, it has those stored away, and it can intercept the system call again, ignore it, and just replace the output that you would get with the recorded one. And then you use something called hardware performance counters to get a specific point in time you can associate with these events. And in this manner, you then have a trace of program behavior over time that you can just replay over and over, which is neat. So why RR is special in particular is that it has extremely low overhead compared to other tools. It's nothing new. Like, this is an idea that's been around since like the early 2000s, and there's a bunch of tools out there. But this is a new one that is aiming for like production quality. We use it on Firefox regularly. It's no good to us if it can't deal with giant programs. And it also, we don't want any kernel modules. We don't want any special hardware. This is just like any stock 32 or 62-bit Linux system can be used with this if it has a recent enough CPU. And it's totally open source. You can look into how this works. That's pretty fun. So, what else can you do with this? It's great that you can travel through time. It's pretty fun. But imagine if all of your testing infrastructure ran under RR. If you have less than 2 times overhead, that means that, like often that's like 1.2 times. That means that like a 10-minute test suite will now take 12 minutes. That's not a big sacrifice. If you then store the recording somewhere, and every time you notice a flaky test that occasionally fails, you can just be like, oh yeah, I'll just grab the recording from another server and I'll just log in there and take a look, whenever I have the time. That's pretty nice. Also, this works on optimized builds, in that if you're ever debugging something in GDB and it's like, oh, this variable that you're trying to inspect is optimized out, well, you can go backwards in time and figure out where the value originally came from, and eventually you'll get to a point where it's not optimized out. Additionally, this is super helpful for debugging time-sensitive problems. For audio-visual stuff, we have a Firefox engineer who's working on debugging why frames are dropped. And if you're debugging in GDB, you'll have code that when it runs, it's like, when was the last time that we ran this code? You have timestamps. If you're in GDB normally, that's like, well, maybe it was like 60 seconds ago because I'm stepping through each line. But in RR, it has a very fixed, it has a fixed point in time that will be the same all the time, and you can actually run logic against that. So that's it. There's really cool things you can do with this. This is a really fun tool to play with, and record and replay makes my life so much better when I get to use it. I love it. I hope you do too. Come talk to me if you want to learn more about how it works. Thank you.